Thunder shakes your chest. It rattles your windows. It sets off car alarms 3 blocks away. When a storm cracks open the sky, you feel small. You feel the raw power of nature. Now look at a light bulb. It's silent. It's gentle. You can put your hand right next to it and you feel nothing, maybe a little warmth. So here is what your brain tells you. Sound is strong. Light is weak. Sound carries the energy. Light is just decoration. Wrong. Your brain is lying to you. Not a little bit. It is fundamentally failing to understand the universe. Here is the truth that's going to annoy you. A simple flashlight carries more energy density than a shotgun blast of sound. The sunlight hitting your face right now is louder, physically, energetically louder than a jet engine taking off next to your ear. We think of light as a ghost, but light is actually a hammer. We just evolved to be numb to the blows. If you could actually hear the intensity of the light around you, you wouldn't be watching this video. You'd be deaf. So why is the most violent energy in the universe silent? And why is sound, the weakling of physics, the only one that hurts our ears? Let me show you. I know what you're thinking. You're thinking, if light is a hammer, why doesn't it knock me over? Why doesn't a flashlight punch a hole in the wall? Fair question. To understand why light is powerful but feels weak, you have to understand that your body is a biased instrument. You are not a perfect sensor. You are a survival machine. Here is the part nobody tells you. Loudness isn't a measurement of energy. Loudness is a feeling. It is a biological panic signal. When a thunderclap hits you, it is crude. It is messy. It grabs the air molecules right in front of your face and violently shoves them into your ear canal. It physically kicks your eardrum. Your brain evolved to pay attention to that kick, because in the wild, a loud noise usually meant a rock falling or a predator charging. Sound is a mechanical assault. Now look at light. Light doesn't shove the air. It passes right through it. But make no mistake, light does push. Physics calls this radiation pressure. When you stand outside on a sunny day, you are being pelted by trillions of photons. They are raining down on you like microscopic bullets. They are physically striking your skin and transferring momentum. So why don't you feel the impact? Because the bullets are too small and the frequency is too high. Close your eyes and imagine this. Imagine someone throws a basketball at your chest. Whack! You feel it. That's sound. A big, slow, heavy impact. Now imagine someone points a fire hose at you, but the water is a fine mist. It hits you with the same force, maybe even more force, but it's spread out over billions of tiny droplets. You don't feel a whack, you just feel pressure. That is light. We mistake sensitivity for intensity. Our ears are basically hypersensitive microphones tuned to detect the twigs snapping in the woods. They amplify weak signals so we can survive. But our skin? Our skin is a solar panel. It's designed to absorb massive amounts of energy without complaining. If you evolved to hear the pressure of photons the way you hear the pressure of air, walking outside at noon wouldn't be peaceful. It would sound like a continuous explosion. The sun wouldn't be warm. It would be screaming. But sound? Sound has a limit, a hard ceiling. And this is where the physics gets weird. Let's try to break sound. I want you to imagine we have a dial that controls the volume of the universe. We turn it up. We get to a rock concert, that's 120 decibels. Loud, but we can go higher. We get to a jet engine, 140 decibels. Your ears are bleeding now. But let's keep going. We turn the dial to maximum. Here is where your intuition fails. You might think sound can just get louder and louder forever, like numbers counting up to infinity. Wrong. Sound hits a wall, a physical, hard wall. In Earth's atmosphere, at sea level, that number is exactly 194 decibels. Why? Because sound is not a thing. Sound is a dance. It is a wave of pressure moving through the air. Try this right now. Clap your hands. When you clapped, two things happened. First, you smashed air molecules together. That's called compression, high pressure. But right behind that smash, the air has to spring back. It has to stretch out to fill the gap. That is called rarefaction, low pressure. Sound is just this: squeeze, stretch, squeeze, stretch. Here is the problem. You can squeeze air as hard as you want. You can compress it until it turns into a liquid if you have enough energy. The squeeze has no limit, but the stretch has a deadly limit. When a sound wave gets to 194 decibels, the stretch part of the wave creates a complete vacuum. The pressure drops to absolute zero. Wait, think about what that means. You cannot have less than zero air. You cannot have negative air. Once the trough of the wave hits a perfect vacuum, the wave breaks. It cannot get any louder because there is no more air left to pull back. The wave physics literally shatter. So what happens if you set off a bomb that is louder than 194 dB? It stops being sound. The energy refuses to travel as a wave. Instead, it turns into a shock wave. It stops vibrating the air and starts actually moving the air. It becomes a wall of compressed wind that pushes everything out of its way. That isn't noise anymore. That is a shove. This is the pathetic weakness of sound. It is a prisoner of the air. It can only swing as wide as the atmosphere allows. It is capped. It is leashed. Light does not have this problem. Light doesn't care about air pressure. You can crank the intensity of a laser up to numbers that would make a mathematician weep, and light just keeps taking it. Sound creates a vacuum and dies. Light travels through a vacuum and thrives. But the reason sound loses isn't just about the vacuum. It's about the sludge it has to swim through. And that is why the universe seems quiet. Let's be honest. Sound is kind of a lazy form of energy. It needs a ride. Sound cannot move without a medium. It's like a person trying to swim in a pool with no water. If there's no air, there's no sound, period. But air is heavy. Here is the part nobody tells you. Air molecules have mass. Every time you speak, your vocal cords have to physically push nitrogen and oxygen atoms. Those atoms have inertia. They don't want to move. You have to force them. Imagine trying to sprint through a swimming pool filled with honey. Every step is a struggle. You lose energy fighting the liquid. That is what sound has to deal with. Every inch sound travels, it loses energy to heat. The air molecules rub against each other, friction. The energy bleeds away. That's why you can't hear a scream from a mile away. The air eats the sound. This is the sludge problem. Sound is fundamentally inefficient. It spends most of its energy just trying to convince heavy particles to wiggle. Try this right now. Put your hand on a speaker playing bass-heavy music. Feel the vibration? That's wasted energy. That's the speaker cone fighting the air, and the air fighting back. Now, let's look at the champion. Light doesn't have this problem. Light doesn't need a medium. In fact, light hates a medium. Light travels best through absolutely nothing. A vacuum is perfect for light. In space, there is no air to push against, no honey to swim through. Light just goes. It doesn't lose energy to friction because there is nothing to have friction with. That is why you can see a star from 1 billion light years away. The light has traveled for eons without losing a single photon to air drag. If sound tried to travel that distance, it would be dead within a few kilometers. Wait, let that sink in for a second. Sound is local. It's trapped on Earth, stuck pushing heavy molecules around like a tired laborer. It's weak because it spends all its energy fighting its own environment. Light is universal. It's free. It carries pure energy across the cosmos without breaking a sweat. But here is the real kicker. It's not just that light travels better, it's what light is actually made of. Sound is just wiggling air. Light is something else entirely. Light is a bullet. This is the part they skip in high school physics. Wait, Let's talk about light again, because light is not just a wiggly line on a graph. Light is a particle. It is a photon. And photons are weird. They have zero mass, none, zilch. If you put a photon on a scale, it would read exactly 0. But here is where your intuition fails. Even though it has no mass, a photon has momentum. Think about that. In classical physics, momentum is mass times velocity. If mass is 0, momentum should be 0, right? Wrong. Einstein showed us the trick. E equals mc squared is the famous part, but the full equation includes momentum. For a photon, energy is momentum. Because light moves at the speed of light, the fastest speed in the universe, it packs a punch that defies logic. It doesn't need mass to hurt you. It needs speed. And it has all the speed. Imagine an ocean made of lead. That is sound. Sound is heavy waves crashing slowly against the shore. It relies on the weight of the water to do damage. It's sluggish. It's brute force. Now imagine a laser beam. A laser beam is a stream of billions of tiny, massless bullets traveling at 300,000 kilometers per second. They don't push the air. They ignore the air. They slam directly into the target. When light hits something, it transfers that momentum instantly. It doesn't wiggle the atoms like sound does. It excites them. It heats them up. It can even knock electrons out of their orbits. That's the photoelectric effect, by the way. Sound shakes the house. Light burns it down. This is the crucial difference. Sound is mechanical energy. It's a push. Light is electromagnetic energy. It's a transmission. Sound fades because it has to drag heavy molecules around. Light flies forever because it carries its own electric and magnetic fields. It doesn't need a medium. It is the medium. So when we ask which is louder, we are really asking which carries more energy, the wobbly air or the massless bullet. Let's put them to the test. Let's make them fight. I want you to imagine a cup of coffee. We are going to try to heat it up using only our voices. The result is going to make you laugh. Let's play a game. I'm giving you a cold cup of coffee. It's sitting right there on your desk. And I'm going to challenge you to heat it up. But there's a catch. You can't use a microwave. You can't use a stove. You can only use your voice. You have to yell at the coffee. Stop. Don't scroll. This is where the physics gets weird. You might think, well, if I scream loud enough, the sound waves will vibrate the liquid, friction will happen, and it will get hot. And technically you are right. Sound is energy. Energy is heat. But how much energy? Let's do the math. The average human shout is about 80 decibels. That sounds like a lot, but in terms of power, it's pathetic. If you yelled at the top of your lungs non-stop without taking a breath for one entire year, you would generate enough heat energy to warm up one single cup of coffee. Not boil it, just make it lukewarm. Let that sink in. A whole year of screaming equals one lukewarm coffee. The total acoustic power of a shouting person is about 0.001 watts. That is 1/1000th of a watt. Now look at a light bulb. A standard old-school incandescent bulb uses 60 watts. Even if it's inefficient and only 5% becomes light, that's still 3 watts of pure light energy. 3 watts versus 0.001 watts. A single light bulb is literally thousands of times more powerful than your voice. And that's just a light bulb. Now think about the sun. The sun hits the earth with about 1,000 watts of power per square meter. That is a kilowatt of energy slamming into every square meter of ground, every second. If you could convert that sunlight directly into sound, it wouldn't just be loud, it would be a weapon. Here is the number that should terrify you. If you took just the sunlight hitting your thumb, your tiny thumb, and turned it into sound energy, it would be louder than a chainsaw right next to your ear. If you took all the sunlight hitting your body and turned it into sound, it would be louder than a space shuttle launch. It would kill you instantly. The shock wave would liquefy your organs. But because it's light, you just feel warm. This is the deception. We think sound is powerful because it hurts our ears. But sound is incredibly weak. It is a whisper compared to the roar of light. Light carries energy density that sound can only dream of. If sound tried to carry the same energy as sunlight, the air would literally catch on fire. The friction would be so intense, the atmosphere would turn into plasma. So why doesn't light deafen us? Why is the most violent energy in the universe silent? Because of how we measure it. There is a hidden mathematical vector that explains everything, and that is why the universe seems quiet. This is the physics nobody talks about. It's easy to say light has more energy, but we have to prove it. How do we measure loudness in physics? We don't use decibels. Decibels are for human ears. Physics doesn't care about ears. Physics cares about intensity. And intensity is defined very simply: power per area. I equals AP. Basically, how much energy is punching through a square meter every second. For sound, this is pitiful. A normal conversation is about 0.000001 watts per square meter. It's barely a whisper of energy. For sunlight, it's 1,360 watts per square meter at the top of the atmosphere. Do the math. 1,360 versus 0.000001. Sunlight is over 1 billion times more intense than a conversation. That is 1 billion times more energy hitting you. But here is where the real secret lies. In electromagnetism, there is a special vector called the Poynting vector. Yes, named after a guy named Poynting, and yes, it points in the direction of energy flow. The Poynting vector, S, tells us exactly how much power light carries. S equals as E times B, electric field times magnetic field. This equation is terrifying. It says that light isn't just a wave, it is a river of power. The electric field pulls, the magnetic field pushes, and together they drive energy forward like a freight train. Imagine a tsunami. Sound is a ripple on the surface of a pond. It moves the water a little bit, up and down. Light is the entire ocean moving. The sheer volume of energy in the electric and magnetic fields is enormous. But because the frequency is so high, hundreds of terahertz, our nerves can't feel the individual pushes. We just feel the average heat. We feel the burn. If you could slow light down to 500 hertz, the frequency of a tuba, you wouldn't just hear a note. You would be obliterated by the sheer pressure of the wave. The Poynting vector proves that light is carrying momentum density that would shatter windows if it was sound. So if we convert that intensity back into decibels, what number do we get? If we take the raw power of sunlight and force it into the language of sound, how loud is the sun? Brace yourself for the answer. Let's translate physics into noise. We know the intensity of sunlight, 1,360 watts per square meter. We know the intensity of a painfully loud rock concert, 1 watt per square meter. Wait, read that again. A rock concert is 1 watt. Sunlight is 1,360 watts. So if you could hear light, if your ears could process electromagnetic radiation as sound pressure, standing outside on a sunny day would be like standing inside 1,360 rock concerts simultaneously. But decibels are logarithmic. Every 10 dB is a 10x increase in power. So let's do the conversion. The threshold of pain for human ears is 120 dB. That's a jet engine at 50 meters. The sun at Earth's surface is 162 dB. 162 decibels. That is louder than a shotgun blast right next to your ear. That is louder than a jet taking off while you are standing on the wing. If the sun screamed at 162 dB, you would go instantly deaf. Your eardrums would rupture in milliseconds. The pressure wave would knock you off your feet. And that's just on Earth. If you were in space, closer to the sun, at the surface of the sun, the intensity is about 63 million watts per square meter. Convert that to decibels, you get 298 dB. Remember our hard limit for sound in air was 194 dB? The sun is 100 decibels above the physical limit of our atmosphere. 298 dB is not a sound. It is a planetary extinction event. A sound wave of 298 dB would carry enough energy to boil the oceans. It would strip the atmosphere off the Earth. It would turn rock into vapor. That is how much power light carries. It is a silent scream that is billions of times more powerful than anything our atmosphere can handle. We think space is quiet because there is no air, but in reality, space is filled with screaming energy. It is a cacophony of radiation so intense it would liquefy us if we could hear it. We are just deaf to the frequency. But the sun is just a medium-sized star. What happens when a star dies? Let's zoom out. If the sun is a rock concert, a supernova is, well, there is no word for it. When a star explodes, it releases more energy in a few seconds than the sun will release in its entire 10 billion year lifetime. A supernova is a gamma ray burst. Think about the loudest sound ever recorded on Earth. Krakatoa, 1883. It circled the globe 4 times. It shattered eardrums 40 miles away. It was estimated at 310 dB. A gamma ray burst is, try 10 to the 44 joules of energy. If you were within a few light years of a GRB and could convert that light into sound, the decibel level would be incomprehensible, trillions of decibels. At that level, the concept of loudness breaks down completely. Energy density at that scale creates black holes. The sound wave itself would have enough mass energy to warp space-time. The universe isn't quiet, it is screaming. Every galaxy, every pulsar, every quasar is blasting out energy that makes our loudest noises look like a joke. But because it's electromagnetic, because it's light, it travels silently through the vacuum. We look up at the night sky and see peace. We see tiny twinkling stars. We think, how serene. Wrong. You are looking at the most violent explosions in history. You are looking at matter being torn apart, atoms being crushed, and energy being flung across the cosmos at the speed of light. It is a battlefield. It is a concert of destruction. But we are lucky. We are deaf to it. Our atmosphere blocks the worst of it. Our eyes only see a tiny sliver of the spectrum. We are shielded from the true volume of the universe. We live in a bubble of silence, but that silence is an illusion. And this leads us to the final truth. And now we have arrived at the answer. Why is light louder than thunder? Because light doesn't need to shout. It doesn't need to shake the air to prove its strength. Thunder is a tantrum. It is a wave of desperation, fighting against the atmosphere, losing energy every step of the way. It is weak. It is mortal. Light is immortal. Light carries the energy of stars across the universe. It carries enough power to burn worlds, enough momentum to push spaceships, solar sails, look them up, and enough intensity to deafen us instantly if we could hear it. We mistake silence for weakness, but in physics, silence is efficiency. The most powerful forces in the universe, gravity, magnetism, light, do not make a sound. They just work. They dominate. The next time a storm rolls in and you hear that crack of thunder, remember this. That sound is the dying gasp of energy. It is the friction of the air complaining. It is the waste product of a lightning bolt. The real power was the flash. The flash carried the heat. The flash carried the electrons. The flash carried the momentum. The thunder was just the applause. So when you walk outside tomorrow and feel the sun on your face, don't think of it as warmth. Think of it as a roar. Think of it as a constant, deafening scream of energy that your body is miraculously able to ignore. The universe is incredibly loud. We are just lucky to be deaf. It's not just light, it's power. And sometimes the most powerful things are the ones you never hear coming. Think about that.